Hello everyone. So today we'll be solving this LeetCode hard problem, rearranging fruits. So the problem states that we are given two fruit baskets, means two arrays, which has n fruits each, and each element means denotes the number of fruits in that particular basket. Now we can like swap means two means we can pick any two index from the both the baskets and perform a swap operation, and the cost of that swap operation will be the minimum of the elements that we are picking up. Now we need to perform these swaps in a way such that the both the baskets become equal. Okay, and two baskets are equal if like after sorting means both arrays, so it should become like a b c d and so on, and the second array should also be a b c d and so on. So after sorting means the frequency of each element in both the arrays should be the same. This is what we do. And if we are not able to like make the both the baskets equal, then we simply return -1. And the constraints are of the order of 1e5. So like trying all the possible means trying all the possibilities of swapping all the pairs means recursively trying it would be like maybe of the order of 2 to the power n, which will not be feasible here. So obviously like we need to think of something greedy or dp or like whatever algorithm we try to define. So like let's first try to get the output for the given input and see like how we can get the result. So since will be sorting the array in the end, so it does not matter like whether we sort the array in the end or in the start, because we'll only need to make the frequency of each element in both the arrays same. So let's like try to sort the array initially only. So what we'll get is 2 2 2 4, and here we'll get 1 1 2 4. Now we need to make both the arrays equal. So this 4 is already equal, this 2 is already equal. Now we want to send 1 1 from this side to this array, and we need to get 1 2 from this array to this array. Alright, so this is what we need to do. So we'll simply like we can perform a swap operation between these two elements. So the cost will be minimum of 1 comma 2, and the new array will become 1 2 2 4, and here after sorting it will be same 1 2 2 4 only, and hence the cost will be minimum of 1 comma 2, which is 1. So hence we have written 1 here. Again like let's see a different input. So for this let's sort it. So it will be 1 2 3 4, and here it is 1 2 3 5. So as you can see like this 5 is not means is only present a single time, and if an element needs to be present in both the arrays like a then bb then bb then cc, so this means like each element means the overall frequency of any element should be even, then only it can be distributed into two baskets, right? So since as you can see like here the frequency of 5 is 1 only, as well as frequency of 4 is 1 only, so we cannot make both the baskets equal, hence we have written -1 here. So this means once we have identified this, so what we can do, we can see like we can first identify elements which are already satisfied, identify elements which means which already have a pair, which already have a pair, right? Means those elements which we do not need to touch to swap. For example, here this 4 already had this 4, so we do not need to like account this 4, and here this 2 already had a 2 on the secondary, so hence we also do not need to account this. So means what will be the like the count of elements which we need to swap. So for suppose we consider element x, and its frequency in first array is like count 1 of x, and in second array it is count 2 of x. So definitely like the overall count will be count 1 of x plus count 2 of x, right? And now after like we have performed swap operations, the number of means count in both the arrays would be divided by 2, because we'll be equally distributing them in both the arrays. So this will be the overall means final count in this, and initially like first array has this count. So how many elements we need to remove from a, the elements number of elements we need to remove from a will be count 1 of x, the initial count, minus the final count that we need. So it will be count 1 of x plus count 2 of x divided by 2. After solving, we get we'll get count 1 of x minus count 2 of x by 2. So this will be the number of means swap operations that we need to perform for x. So hence, if we find the frequency of each element in both the arrays and take the difference, then that will be the number of operations that we need to perform, assuming that this count 1 of x is greater than count 2 of x. If means it is less, then we will perform the swap operations from the second array. So we'll simply we can take the absolute of this to know the number of swap operations that we need to perform. And along with that, since we are rejecting some elements, we can keep these elements in like a separate list, suppose say. So separate, how we can keep it in a separate list? So this was the number of number of elements which we need to move from array A to array B. Okay, so let's create a separate list which will have means these many elements. For example, here count of 1 is same. For example, here the count of 1, count 1 of 1 was 0 and count 2 of 1 was 2, and divided by 2 is minus 1. So and we'll take absolute of minus 1, which gives 1. So we'll put 1 1 in this array. Okay, these many times means this one we need to swap. Along with that, the count of 2, which was 3, minus count of 2 in this array 1, divided by 2, which is 1. So again we need to just move one single 2 from A to B. Now these are the elements which we need to swap. We'll create a separate list for these elements. Now how do we pair these elements? So you might think we can simply pair the smallest element and the largest element which will be present at the end of array, so that the minimum always will be the minimum element at the start. So this is the approach, means we can think greedily. So let's try to see the overall approach that we discussed till now. So what we discussed was, for the two baskets to be eventually become equal, the combined total count of every specific fruit cost x must be even, right? Each fruits must have an even cost, then only it can be distributed among two baskets. So let's count total x be the occurrence of x in both baskets combined, and after the means we have redistributed, the count of x in each element, each array will be count total of x divided by 2. Now if this count total of x divided by 2 is odd, then it is not an integer, hence we cannot redistribute. So we'll simply return minus 1 in this case. Okay, now once we have handled the minus 1 case, we need to identify the set which we do not care about again. Means since we'll identify, so suppose this 4 already has a 4, this 4 already has a 4, this 2 already has a 2 in there. So we do not care the means number of times, means which element is being swapped, right? Whether it was 4 3 and then 3 4 4 3. So whether it was 3, we are swapping 3 or we are swapping 4, it does not matter. Only the count of each element matters, right? I hope you get why here only the count is being mattered here. Okay, so let count 1 of x be the count of x in basket 1, count 2 of x. So the balanced target count will be this. So if count 1 of x, this is the same proof that I did above, will be the quantity to move would be count 1 of x minus this, which will finally give us this value, the same result that we derived above, count 1 of x minus count 2 of x divided by 2. Okay, now once we have this, what do we do? We try to generate a list of the elements which we need to swap, so that we can pair the minimum element with the maximum element and easily swap them, so that only we require, means only account the minimum cost that we require. Okay, and the maximum will be skipped, hence the overall cost will be minimized. So for example, if basket 1 has 2 extra hundreds, so we will add 2 extra hundreds, means the extra count is given by this, the number of swaps that need to perform. So the S will have 5 5 100 100. We'll simply perform swap of this and this, and then swap of this and this. So you'll get 5 plus 5 equals to 10. Okay, maybe the array would have looked like, since it had two extra hundreds, so it would have like 100, 100, 100, 100. Then only these two are extras here. These needs to be fit here, and we had 5, 5, 5, 5. So these two fives are extra. We need to move it to this side. All right. So this was the algorithm that we needed to find. We find out the extra means elements which we need to swap, and then create a separate list and try to pair it with the maximum element, and then only the cost will be minimized, so that this cost is never accounted for and we have already swapped this element. Now, like whether this condition only will minimize the cost. So the answer is no. Why? Let's discuss it. Means only pairing the minimum with the maximum will always give us the means correct answer is not correct here. Let's try to see why. So we had like swap cost equals to minimum of u comma v. Now to minimize u comma v, we should sort as in ascending order and we pair the smallest elements with the largest elements. But this approach is not correct. Why? Because suppose the elements was like something this, where all elements that we need to swap. So after the swap list, so for example, A had 1,000, and B was 1, 2,000, 2,000. Now the swap list will have, since this one is already counted, this 1,000 is extra, so swap list will have 1,000, and this 2,000 is extra, so we'll swap list will have 2,000. Now why? So in this case, the cost will be minimum of 1,000 comma 2,000 will be cost will be 1,000. But this is not correct here because we are not utilizing this one here, because here one is very small. So maybe we can utilize one in a way such that we do not need such a such a great cost for swapping operations. So what we can do is, since we need to like bring this 2,000 in this array, so maybe we perform a swap with 1 and 2,000. So what will be the new array? It will be this 2,000 come above, 1,000, 1,000, and the B array becomes 1, 2,000 and 1. Now this 2,000 is satisfied. We need to satisfy this 1,000. So again, since 1 is not satisfied, so we can swap 1 and 2,000, 1 and 1,000. So the new array will become 2,000, 1,000, 1, and it will become 1, 2,000, 1,000. And now we can see like every pair has a corresponding pair. Every element has a corresponding pair. So hence this is balanced. And the cost required was 2 into 1, because once we send the minimum element to this array, and then we brought the minimum element back to the first array. Right? So what will be the final formula? The final formula will be, once we have created the swap array, the total cost will be what? It will be minimum of what? The leftmost element, because we are taking the minimum of this and this. So hence always the leftmost element will be the minimum, right? Because the greater elements means larger elements are present on the right side. Hence we have already sorted this swap array. So it will be minimum of swap of I, comma 2 into, since 2 into the minimum element present in array, minimum in both arrays. And how will we use this minimum? Will you first send this minimum to the second array and then we'll bring it back. And if this means means lesser cost, then you will be performing this, or will simply perform the pairing of smaller and larger elements. And how which loop will this? So suppose size of this is m, so it will be till like summation I equals to 0 till what? Since we have a size m array, so it will be till 0, 1, 2 till m by 2 minus 1, right? Means only the, since this array will have even numbers, even numbers only. Hence, uh, we'll only account the first half of these numbers, which will be till m by 2 minus 1, because these are the minimum elements we will be considering, and these will be greater, so we'll make a corresponding pair with the smaller elements. And at each step we also take this, because whether we using the minimum will be better here or not. So this will be the overall formula that we'll be using. Now let's see the code as well to see how we will be implementing it. So first I have created this map because we wanted to find out like count 1 of x minus count 2 of x divided by 2. This is what we needed to find to create the swap list. Okay, so we created this map now, and also created this mini variable so that we can easily like use this 2 comma mini in subsequent formulas. So we calculated this mini variable as well. Now in from element means array 1 we are increasing the count, and from array 2 we are decreasing the count of x. So this is what we'll do. We'll increase the count of element in map from array 1 and decrease it from array 2 and find out the global minimum that we have. Now we need to create this swap vector. So we create this swap list and iterate through the map. Now if the excessive elements that we have like 1 2 3 4 1 2 3 5, so if the count of these excessive elements is odd, then we simply return -1. Okay, else we need to find the moves, number of moves that we will form here. So till now we have this diff. This diff will be count 1 of x minus count 2 of x, but moves was count 1 of x minus count 2 of x divided by 2. So this will be the moves, and these many times this particular element will be the part of the swap array that we have. So we push this element in the swap array the number moves number of times, and we finally sort it so that we can pair the smaller element with the larger element at the end. And also means use the same formula that we discussed. We account 2 into many, whether like the same case 100 100 and 1 200 200. So instead of like swapping 100 and 200, we'll swap first and 200 first, and then bring the first by swapping 100. So this 100 will come down and this 200 will go above, and the final array would become equal after sorting. So this will be the approach, and we finally return the result. So this will be the approach for this problem. The space that we are using is of big of n, and the time complexity is, since we are swapping means sorting this, so it will be big of n log n. So overall complexity is big of n log n, which is acceptable since the length is up to 1e5 only. So I hope like you get the overall logic of how we are just using the count of each element to decide whether we can make both the arrays equal or not. And just on the basis of counts of each array, we create the swap list, and then we need one observation was needed, like we, apart from just pairing the smaller element with the bigger element, just pairing the smaller element with the bigger element was not sufficient. We also need to account the case where the elements which we are swapping is very high. In that case we can account the minimum as well, so that we can send it here and then bring it back utilizing a cost of 2 into mini, and at each step we calculate this minimum. So let's submit the code as well once to see how well it performs. So as you can see, like it runs in 37 ms, which is n log n, so it is completely fine. So yeah, this was the overall logic for this problem. If you have any doubts, feel free to comment down and I will be happy to respond. Thank you for watching.